Hello, welcome back to Matrix and Determinant. My name is Oluwafemi Godogbe. So today we'll be checking the determinant of a 3 by 3 matrix. It's not as easy as the 2 by 2 matrix. There are some terms that you need to have their understanding before you can actually find the determinant of a 3 by 3 matrix. So the first thing is the minor. So the minor of an element of a 3 by 3 matrix is the value of the 2 by 2 determinant obtained by covering of the row and the column and the column containing that element. For example, now if you have this 3 by 3 matrix A, B, C, D, E, F, G, H, I. So the minor of an element, so for example now the minor of this element D is the value of the 2 by 2 determinant obtained by covering up the row and the column containing that element. Let me change my pen. So the row and the column containing this element D is this first row. Sorry, let me change this pen. Is this first row 1 and then is that row, sorry, column 1 and row 2. So the remaining elements left, that is B, C, B, C, H, I, H, I. So then the determinant, that is Bi minus Ch. So the minor of element, we can answer that the minor of element D is Bi minus Ch. Do you see that now? So the rule is that you cover the row, the column and the row corresponding or containing that particular element whose minor you want to find. So that's how to find the minor of an element in a 3 by 3 matrix. So the next you need to take note of before we start taking the example on this figure 2 is what we call the cofactor. So the sign of a minor depends on its position within the matrix. Within the matrix, and we have the sign pattern and the sign pattern for the matrix. And to write this. Okay. So within the matrix, the sign pattern B. So we have for a 3 by 3 matrix, we have plus minus plus minus plus minus plus minus plus. So that is the sign pattern. You have to take note of this. Very easy. Plus minus plus minus plus minus plus minus plus. So for our previous matrix we check now. So does the signed, that's that does the signed minor of element D. Don't forget this, the position of our element D. That will be negative. Is negative. That means that we are going to find the negative determinant. What we call it now, BCHI. BCHI. So this will give a negative result, minus BI minus CH. So take note of this now. The signed minor, of an element is called the cofactor. The cofactor of the element. Very important. So lastly, the last thing to have at the center of your mind, by the time we'll be checking the inverse of determinant of 3 by 3 matrix, is that the value of a 3 by 3 determinant is the sum of the products of the elements and their cofactors of any row and column. It can be any row or any column. And most students are sticking to just row, which is not so, of the corresponding 3 by 3 matrix. So that means that we have 6 different ways of evaluating a 3 by 3 determinant. 6 different ways, and the answer will all be the same. So let's check this example, then you understand what I'm talking about. Example 1. I find the determinant, find the value of 3, 4, minus 1, 2, 1, 0, 7, minus 3, minus 2. Okay. So to find the value of this determinant, you can choose to go by row, by column, by first row, by first column, anyone, and your answer will be the same. So let's see how it works. You have 3, 4, minus 1, 2, 0, 7, 1, minus 3, minus 2. You can decide to go by this, picking this first rule, which many students are fond of, and that is the only way they know how to find it. They pick only this first rule, and that's what they will be dealing with. So let's first of all deal with this general union. So if I pick this first rule, let me first deal with this first element 3. So dealing with first element 3, I have to cover every other part of the column. So if I cover this, so I'll be left with 0, 7, 3, minus 1. So I'm going to have 3, 0, 7, minus 3, minus 2. Then the second element in the first row, I have 4. And don't forget the position of 4. That is negative. So I'm going to have minus 4. Then if I cover this, so I'm going to have 2, 1, 7 minus 2. 2, 1, 7 minus 2. Lastly, I have minus 1, and the position of minus 1 is positive, and positive times negative, and 1 is negative 1. Then if I cover this, I'll be left with this. That is 2, 0 minus 3. 1 minus 3. So I find the result. We have 3. The determinant of this minus 2 times 0 is 0. Minus 7 times minus 3, that is minus 21. Minus 4. Minus 2 times 4, minus 4. Minus 7 times 1, 7. Minus 1. Minus 3 times 2, minus 6. Minus 0 times 1 is 0. So we have 3 is 0. That is minus 21 times minus, that will give me 21. Minus 4, minus 4, minus 7. That is minus 11. Minus 1. And minus 6 minus 0, that is minus 6. So 3 times 21, that is 63. And minus 4 times minus 11, that will be minus, sorry, that will be plus 41. Plus 4, 444. So minus 2 times 2 plus 6. So if we sum up this, that will be 63. And 63 plus 44, and then plus 6. We have 113. 113. So this is 1 out of 6 ways you can find determinant of 3 by 3 matrix. Here we make use of the first rule. Make use of the first rule. So let me just pick any random. Let me make use of column now. Let me pick second column. Using second column. Second column. Then you see that the result will still be the same. So there are 6 ways whereby you can find a determinant of 3 by 3 matrix, not just the only single way you knew. But just make use of the first rule. We have 3, 4, minus 1, 2, 0, 7, 1, minus 3, minus 2. So I'm going to pick this second column and the matrix. Okay, so I'm going by 4. If I pick 4 and the position of 4, that is minus negative, so I'm going to cover this first row. So I'm left with 2, 1, 7 minus 2. 2, 1, 7 minus 2. So the second element, which is 0, where we have plus, let me write it here, sign plus, minus, plus, minus, plus, minus, plus, minus, plus. So I have positive 0. Then if I cover this second row, I'm left with 3, 1, minus 1, minus 2. 3, 1, minus 1, minus 2. Then that's the last element, that's negative 7, because the position of 7 there is negative. So, oh sorry, I'm dealing with minus 3 rather. So the position of minus 3 here is negative, and that negative will affect this negative. So I'm going to have plus 3. So if I cover this last row, I'm going to have 3, 2, minus 1, and 7. 3, 2, minus 1, and then 7. So here now I'm dealing with the second, I'm using the second column instead of row. So minus 4, and let's see what the result will give. Minus 2 times 2, that is minus 4. Minus 1 times 7, 7. Plus 0. Minus 2 times 3, minus 6. Minus 1 times minus 1, minus 1. Just be careful of negative. They are very dangerous. 7 times 3, 21. Minus 2 times minus 1, minus 2. So we have minus 4, minus 7, minus 4. That is minus 11, right? plus 0, that's minus 6, minus times minus plus 6, that's minus 6 plus 1, that will be 5, and that will be minus 5, plus 3, that will be plus 2, and then that will be 21 plus 2, that will be 23. Okay, this time that will give me 44 plus 23 times 3, that is 69. So if you also add up this, you are going to have 113, which is the same size using the first row you are used to. So you can pick any row, you can pick any column to find your determinant, and the result will still be the same. So anyone you are good at, you are free to make use of it. Alright, thank you for watching. I hope to see you in the next video whereby we're checking the inverse or reciprocal of a 3 by 3 matrix. Thank you.